Hello everyone, welcome to our channel Maxotech. You are watching series Wireless Sensors Networks. This is the sixth part of the series in which we are going to look at data collection tree-based logarithm. This covers the definition of tree-based data collection logarithm, and also we look at how the pseudocode of this logarithm looks like. Then we will proceed with how this logarithm works in a real-world example, and then we will gonna study about the properties like message complexity, time complexity, and in the end, we are going to conclude by looking at the advantages and the disadvantages of this logarithm. So let's get started.
So in this logarithm, a message M is spread across the entire network based on a spanning tree. The logarithm is pretty much simple as we already have studied how spanning tree works. So the sync node and R sends the message M to all of its children in a spanning tree. Each children node then, upon receiving the message, forwards the message M to all of its children in the spanning tree. Similarly, the process goes on until all of the nodes in the network have received the message. If we recall ourselves how a spanning tree is different from a normal graph, in general, the given graph is a general graph if we take all of the edges, including the dotted lines too. But if we exclude the dotted lines, we end up creating a graph with no loops and no cycles, which is called spanning tree. So the message M is sent across every child node of the root node, which then gets forwarded to all of the child of received nodes. Similarly, it goes on until all the nodes have received the message M. So looking at the message complexity, every edge of a spanning tree transfers exactly one message. So the total edges in a spanning tree are total nodes minus 1. So the message complexity is n minus 1. Looking at our last example, to broadcast this message M, it has to travel 6 times in a network. Message first came into these two edges and then to these 4 edges. So total makes 6. And this logarithm works the same for synchronous and asynchronous execution. Time required for a message M to reach all of the nodes from a root node is considered as single time step t. So we say that d is the depth of the spanning tree. So the deeper the spanning tree, the more time it will require to reach the message to all of the nodes. So the time complexity is directly proportional to the depth of the spanning tree. So to conclude this tree-based logarithm, two of the biggest advantages of this is that it is fast. It starts based on a spanning tree. It is highly efficient, so the messages and the time complexity will increase equally based on the size and the number of the nodes and the tree depth. But talking about the disadvantages, one of the biggest one is that it is fragile. So you know the property of a spanning tree where every edge is a cut edge. So if any linkage breaks, we end up in two separate components of the tree graph, which will break the connectivity of the entire graph.
That is all for this video. I hope it was informative for you guys. If it was, please don't forget to thumbs up, leave a comment if you have any questions, and subscribe if you are new to this channel. This is going to keep us motivated to bring such useful stuff to you guys in the future. In the next video, we are going to look at gossip logarithms, and we will study how gossip logarithm is better than tree-based and the floating-based logarithms. So stay tuned. I will see you in the next one. Till then, take care. Bye.